Here's an idea for you: can we actually move our entire planet? It's a question that sounds like it belongs in a science fiction movie, but let's play with the idea for a moment. Our Earth, as it is already in constant motion in not just one but three different ways at the same time. First, it rotates on its own axis, giving us day and night. Second, it orbits around the sun, giving us our seasons and our year. And third, it travels through space along with the entire solar system at an incredible speed. That's a lot of movement already, but what if we, as humans, wanted to do more than just hitch a ride on this cosmic journey? What if we tried to influence or shift the Earth's movement ourselves? Sounds ambitious, right? Let's begin with something basic. What if every human being on the planet, every single one of us, decided to jump at exactly the same time? It might seem like a fun, harmless experiment. Maybe we could cause a massive earthquake or alter the Earth's trajectory just a little bit. With over 8 billion people on Earth, surely that kind of simultaneous action would have some effect, right? After all, that's a huge number of people generating a massive burst of energy. Sounds impressive, doesn't it? Well, let's break it down with some science. The idea is fun, but unfortunately it wouldn't do much. In fact, the result is almost laughably underwhelming. When billions of people jump at the same time, the Earth feels it, but only in the smallest way imaginable. It's like tickling a sleeping giant. The giant may twitch slightly, but it doesn't wake up, let alone move. To understand why, we need to look at the numbers involved. The mass of the Earth is roughly 1.3 times 10 to the power of 25 pounds. That's a number so massive it's hard to even comprehend. Now compare that to the average weight of a person, which is about 136 pounds. If we multiply that average weight by the 8 billion people on the planet, we get a combined human mass of around 1.088 trillion pounds. Sounds like a lot, right? But compared to the Earth's mass, that figure is barely a drop in the ocean. It's not even close. In fact, the total mass of all humans combined doesn't even come close to the kind of forces that Earth naturally handles on a daily basis. Think about weather patterns, ocean currents, and even the gravitational interactions with the moon and the sun. The Earth is constantly in motion due to forces far greater than what we could ever hope to apply. For example, the Gulf Stream, one of the major ocean currents, moves somewhere between 30 to 150 million tons of water every second. That's a staggering amount of mass being transported across the globe. And that's just one current among many. The Earth's atmosphere itself is even heavier, containing a mass with 18 zeros. These air masses move due to solar radiation, temperature gradients, and Earth's own rotation. They are immense and in constant flux. So when we all jump together, even though it may seem powerful to us, it's like a feather landing on a boulder. But let's say we go ahead and jump anyway. What happens then? According to physicists, when people jump simultaneously, their individual efforts actually cancel each other out. Each person's jump gives a tiny push downward, but because we're scattered all over the planet and jumping at slightly different angles and times, even if we think it's simultaneous, the net force doesn't align in any meaningful way. Plus, the Earth itself absorbs our landing impact without any issue. It's like throwing a pebble into the ocean. It makes ripples, sure, but the ocean doesn't care. So instead of shaking the planet, our synchronized jump would be absorbed into the Earth's mass like nothing happened. Maybe, just maybe, it would cause the tiniest of seismic ripples, something that only the most sensitive equipment could detect. But it wouldn't change the course of the Earth's movement or structure in any meaningful way. The planet is just too massive and stable for us to influence it by jumping around. At best, we might make a blip on a seismograph, and even that would be temporary. Alright, so the global jump is out. But what about running? Let's say that instead of jumping, every human being on Earth started running in the same direction at the same time. Would that collective motion have any significant effect on the Earth's rotation or its orbit around the sun? Sadly, the answer is still no. Even if 8 billion people were sprinting at top speed, the force we could generate together would still be negligible in the grand scheme of planetary physics. The Earth simply wouldn't notice. Part of the reason has to do with a concept called angular momentum. Think about sitting in a spinning office chair. When you pull your arms in close to your body, you start spinning faster. When you extend your arms outward, your spin slows down. This is angular momentum in action, and it's a key principle in rotational motion. Angular momentum is the product of an object's rotational inertia and its angular velocity. In simple terms, it's a way of describing how hard it is to stop something that's spinning. Now apply that to the Earth. Our planet is a massive spinning object with a tremendous amount of angular momentum. It's rotating at about 1,000 miles per hour at the equator and weighs an unimaginable amount. Changing its rotation would require a truly colossal force, far beyond anything humanity could produce. And here's the catch. Angular momentum tends to be conserved. That means unless an external force acts on a rotating body, its angular momentum will remain constant. This is a fundamental law of physics, and it's one we can't bypass just by running in unison. Because we're already a part of the Earth, any force we exert on it is internal to the system. In physics, internal forces don't change the motion of the system as a whole. It's like trying to lift yourself off the ground by pulling up on your own shoelaces. It's just not going to work. So, even if everyone on Earth sprinted westward at the same moment, we wouldn't change the Earth's spin or trajectory. We're passengers on a moving ship, not the engines driving it. But okay, what if we get more ambitious? Instead of just jumping or running, what if we use technology? Could we use machines to push the Earth? Could we build enormous thrusters to change our planet's course or rotation? This is where the idea starts to sound like pure science fiction, and in many ways, it is. To shift the Earth even slightly, we'd need to overcome the gravitational forces that keep it in its current orbit and rotational state. That means applying an unimaginable amount of force, and sustaining that force over a long period of time. The amount of energy required would be truly astronomical. We'd need technology far beyond what we currently possess. Maybe one day we could use advanced propulsion systems, like massive ion engines or nuclear thrusters, to try and steer the Earth. These are the kinds of propulsion methods you hear about in space travel theories, and even they would struggle to move something as huge as a planet. We're talking about energy sources that could rival the output of the sun. Imagine for a moment that we somehow managed to build these enormous thrusters and power them up. We'd have to carefully calculate the direction and strength of the thrust to avoid causing catastrophic effects. And speaking of catastrophic effects, let's say we actually succeeded in nudging the Earth even just a little. The results would be dramatic, and not in a good way. The ground would begin to shake violently, as if the entire planet had been rattled like a bell. Seismic energy would travel through the Earth's crust, creating massive earthquakes that ripple out across continents. Buildings would sway and crumble, roads would crack open, and cities could be reduced to rubble. The energy from this shakeup wouldn't stay local. It would circle the globe, igniting fault lines and triggering volcanoes in distant regions. Imagine a chain reaction of destruction stretching across the entire planet. Tectonic plates, those massive slabs of rock that make up the Earth's surface, would be jolted out of place. Some might crash into each other, causing devastating earthquakes, while others might pull apart, opening up gaping rifts in the land. Mountains could collapse, valleys might deepen or shift, and coastlines would likely be redrawn by the chaos. The destruction wouldn't stop there. Massive tsunamis would be unleashed as the oceans responded to the sudden movement. Walls of water hundreds of feet high would surge toward land, destroying everything in their path. Entire cities could be submerged and coastal regions would be devastated. The human toll would be enormous, and the environmental impact would be just as severe. Volcanoes around the world might awaken from dormancy, spewing ash and lava into the air. The sky would darken with clouds of volcanic dust, which could travel thousands of miles and block sunlight. This could lead to a phenomenon known as a volcanic winter, where temperatures drop significantly, crops fail, and ecosystems are thrown into turmoil. The balance of nature would be upended. Animals would lose their habitats, migration patterns would be thrown into chaos, and countless species could face extinction. Entire ecosystems could collapse under the weight of these sudden changes. Forests might catch fire from volcanic heat, rivers could change course, and deserts might expand into formerly fertile areas. The web of life, so delicately balanced, would begin to unravel. The atmosphere itself could be altered by the upheaval. Changes in air pressure and temperature could create massive storms, super hurricanes, or prolonged droughts. Air quality would plummet as volcanic ash and dust filled the skies. People would struggle to breathe, crops would die from lack of sunlight, and economies could collapse under the strain. So, in our quest to move the Earth, we'd be unleashing a chain of disasters so severe that they could threaten the survival of humanity itself. The irony is that we'd be doing all this damage in an effort to achieve something that we probably don't need to do in the first place. The Earth is already on a perfect course, spinning and orbiting in a delicate balance that has sustained life for billions of years. So maybe, instead of trying to move the planet, we should focus on taking better care of it. After all, it's the only home we have. Let's marvel at the natural forces that guide our world through space and appreciate the stability and safety they provide. Trying to push the Earth around isn't just impossible, it's also unnecessary. That's it for today's thought experiment. If this expanded your understanding and gave you something to think about, make sure to like the video, share it with your friends, and stay curious. Who knows what other questions we'll explore next?